Hi guys, I'm back with another unique concept of physics, and this time the concept belongs to geometrical optics or ray optics. Okay, so this is introductory, and this is a simple concept of geometrical optics. That how will we calculate the velocity of image formed in the plane mirror in the case when plane mirror is also moving. So let us consider an example in which I've taken a plane mirror whose velocity is shown here. Its velocity is Vm, and Vm is equal to minus 10 I cap and 5 j cap. This is moving in second quadrant, you can see here. Now this is y-axis and this is x-axis. This is positive x-axis and this is positive y-axis. Okay, so there is an object here. This is an object whose velocity is VO, and this object is moving in first quadrant. In fact, the velocity of object is given as 3 I cap plus 4 j cap. Okay, so it is moving in first quadrant and the mirror is moving in second quadrant. Now we have to firstly take the components of these velocities in two directions, not in x-axis or not in y-axis. In fact, these two directions in which we have to take the components is the direction along the principal axis. This is the principal axis, so we have to resolve the velocities along the principal axis, and the other component is in the direction perpendicular to the principal axis in this. So I'm taking firstly the velocities along the y-axis, which is perpendicular to principal axis. Now if we the velocities are already being resolved and it is being given in vector form, so velocity of object in y-axis is already given as 4 meters per second, as well as velocity of mirror in y-axis is given as 5 meters per second. And we know a simple concept that in plane mirror, the distance of object from the mirror, this distance is equal to the distance of its image from the mirror. This distance, this is equal to this. So these two distances are equal. Now there is a concept which I have already demonstrated in my previous videos, that irrespective of the fact that the mirror is moving or not, here I am talking about plane mirror only. Okay, so this concept is only applicable to plane mirrors, that irrespective of the fact that mirror is moving or not, the velocity of the object and the image perpendicular to the principal axis, this is principal axis and I am talking about the direction which is perpendicular to the principal axis, perpendicular to the principal axis is equal. I have highlighted this word equal. So it doesn't matter that while the mirror is moving or not along the perpendicular direction of principal axis. In fact, the thing which matters is the fact that the velocity of object and the image is equal, and is equal in direction as well as in magnitude. Therefore, I can say that the velocity of image along the direction perpendicular to principal axis will be equal to 4 meters per second only. Okay guys, now we will talk about the velocity of image in the direction along x-axis. X-axis is also the principal axis, so we are talking in the direction parallel to the principal axis. So I've already resolved the velocities. In fact, it is given in resolved form only. Now the mirror is moving in backward direction in left side, which is given as minus 10 I cap, and the speed of the mirror is 10. Okay, this is in a standard unit, that is meters per second, so I am omitting to write that. And the velocity of object is towards right side and is in positive x-axis. You can see that. Now we already know a formula, a direct formula, that is Vi is equal to 2Vm minus V0. For those who don't know the formula, let me give you a hint that parallel to this is parallel to principal axis, VOM is equal to VIM with a negative sign, which means the velocity of object with respect to mirror is equal to velocity of its image with respect to mirror, but with a negative sign, which means that these two velocities relative to the mirror are equal in magnitude and opposite in direction. So by applying the formula of relative velocities, you can derive this relation. Vi is equal to 2Vm minus V0. So Vi is equal to, by putting the values of Vm in vector form. Mind you, this formula is valid in vector form. So by putting these values in vector form, Vm along the direction parallel to the principal axis is equal to minus 10 I cap in vector form, and Vo is equal to 3 I cap. So the answer would be minus 23 I cap. So conclusively, the velocity of image Vi is equal to minus 23 I cap plus 4 J cap. So guys, thank you. I hope you understand the concept, and by this method and by this formula you can calculate the velocities of image in parallel mirror, that is plane mirror only. Okay, so keep watching. Please subscribe our channel for more these kind of videos. Thank you.